Hello, good morning, guys. Hope you are all doing well. So our first question of today's lead code contest 489 is toggle light bulbs. So the first question is what it states is you are given an array of bulbs of integer between 1 and 100. There are 100 light bulbs numbered from 1 to 100. All of them are switched off initially. For each item bulbs I in array bulbs, if ith bulb of light is currently off, then switch on, otherwise switch off. Return the list of integers denoting the lights that are on in the end, sorted in ascending order. No bulb is on, then return the empty list. So what we are state is first requirement, that is what we know is that we are given a 100 bulb from 100 to 100. So bulb of I, which is constraint, that is less than equal to 100. What is the second thing is given as in let's check the constraint, that is length of bulb is 100. So bulb dot length is less than equal to 100. So and the third thing, what we have to return an array list, which is in ascending order. So this is what we are given and this is what we have to return. So what comes in my mind for the first is we have to check if bulb of I is earlier there or not. What is its current state? So what I was looking for first is map, like value, and then we can go forward with like current state, that is boolean, like if uh, on then true or off is equal to false. So for while going from I, that is 0 to the length of 100, 99, that is the length. So what I was checking is if it is present, if present, then change current state, or not present, then add it with on state. So this was I was thinking, and then when we have to return the value, we can make an array list where we can store the values, like all the values where current state is on, uh, values for where current state is on. So that's what I was doing, and then we can just sort the list and return, but it feels a little complex in time and space complexity for the higher values. Like if we are having the length of 100, so we are checking it continuously and then we are sorting it, so it makes it approximately of O raised to n log n. So which is the time complexity of sorting and extra plus n plus maps value, that is we are checking the current state of every value. So it feels a little bit complexer, so I decided to go with boolean array, which can be of length is equal to 100, where as we have given as a constraint that it will not be more than 100, so the length is 100. So when I go through bulb of I, so what will happen here is like I'm going to check whether it's on. So I will check the boolean array and just update it. So like this, for bulb of I, that's it. And I can this array initialize initialize as false for every value, and then update it. And then I can make a for loop where I can go from 1 to 100, and then for every value when boolean of I is true, we can add it into array, add into list. That's it, and then return list. So what time complexity is been saved here is, we don't need to sort the array, we don't need extra space, like mapping space. So what is the time complexity over here is o raised to n plus 100, which we know as which can be denoted as 100 can be 1. So the total time complexity is o raised to n, while space complexity is o raised to 100, which can be o raised to 1. That's it. So this is what our algorithm looks like, pseudocode. Now going towards the code. So this is what our code is like. We are initializing a boolean array, and then for every bulb we can turn it on or off as per its last values or last state. And then for we can making a list which we have to return, and I can run it from 0 to 100 and 100. That's if the value is on, so just add it into the list and return the array list. That's it. Thank you very much.